Hello everyone. It's a great honor to be invited by the UAA to share my talk in this plenary session, Bridging AI Frontiers and Urology, How Multimodal and Agentic AI Will Shape 2025. I am Dr. Tsai from the Far Eastern Memorial Hospital, Taiwan. This is a trailer. In the final section, we will discuss, do AI large language models outperform human experts? We will be benchmarking 15 models in stage 4 prostate cancer for risk assessment and feature stratification. The field of AI includes machine learning, natural language processing, expert systems, and computer vision. Since 2023, large language models have integrated tasks like Q&A, text generation, and translation, allowing a single model to handle all text-based work. By 2024, they've advanced further to handle multimodal inputs, including audio, images, and video. OpenAI categorizes artificial general intelligence, AGI, into 5 levels, similar to the levels of autonomous driving. Level 1 is the familiar chatbot for Q&A. Level 2 requires reasoning capabilities, found in what we call reasoning models, like OpenAI's O1 and O3. Level 3 is our main topic today, the AI agent. The key feature of an agent is its ability to make decisions and select the right tools for execution, going beyond simple Q&A. We are currently between Level 2.5 and Level 3, while Level 4, Invention, and Level 5, Organization, are still under development. Looking at the ultimate vision of AGI, although the timeline is unknown, the path from 2023's LLMs to multimodal LMs and toward 2025's agentic AI brings us ever closer. LLMs, or large language models, are a major breakthrough in generative AI based on the transformer model. Multimodal LLMs can perform text-to-image generation, creating images that have never existed before from simple text descriptions. Generative AI is rapidly transforming various industries, including text generation, translation, and coding, as well as visual content recognition and description and developments in life science. Today's topic, agentic AI, is different from generative AI. While generative AI produces content, agentic AI acts like a brain that can make decisions and plan. It autonomously plans the steps to complete a task and then generates an action, such as booking a flight, placing a stock order, or making an online purchase. This is an AI agent. An AI agent has a core reasoning module, or brain. After defining a goal, it analyzes the problem, retrieves solutions from its memory, and decides which tools to use. After making a decision, it generates actions, observes the results from the environment, and reflects on them to decide whether to continue the loop. This gives the agent a high degree of intelligence. From a personal perspective, an AI chatbot can assist with academic writing. A more advanced agent can perform deep research, automating web searches and literature reviews. The highest level, a personalized assistant or automation tool, functions as an interactive agent that can interact with the external environment. Let's first focus on the second level, the deep research agent, which is highly relevant for academic work. This type of deep research agent, using reasoning models like OpenAI's latest O3, can automate web searches. Its knowledge is therefore not limited to pre-trained data. It can find the latest information to generate reports. This process requires significant reasoning to evaluate and select data sources before compiling a final, comprehensive report. A deep research agent incorporates AI functions from levels 1, 2, and 3. It can search, reason, make autonomous decisions, and organize a report. In this urology example, the prompt asks for an in-depth analysis of triplet therapy for metastatic prostate cancer, including its benefits, drawbacks, and side effects, and whether it is superior to doublet therapy. Once the request is confirmed, it acts like your research assistant, automatically searching for various resources online. It transparently displays its entire process, including its search plan and reasoning steps, allowing you to see its sources, analytical goals, citation judgments, and overall progress. This is the final output. You can scan the QR code for the full text. The quality of this review article is very high, even including a comprehensive comparison table. A more advanced research agent architecture is a multi-agent research system. When a user makes a request, an orchestrator acts as the central command. It determines the necessary search tools and other tools, queries the memory database, and assigns tasks to subagents. For example, a dedicated subagent might be responsible for adding citations and references after the main text is written. We've just used the personal research agent as an example to introduce the concept of an agent. So what exactly is agentic AI? An AI agent is like a brain, an organizer, or a conductor. Based on the task requirements, it acts like a head coach, dispatching the appropriate models, such as ChatGPT, Llama, or Claude, to analyze data and use tools. This conductor must be able to autonomously generate decisions and execution steps without human intervention. A multi-agent system is far more complex. The orchestrator analyzes the problem, queries its memory, and decides which tools are needed, such as checking a calendar, searching the web, or accessing a profile. It dispatches tools to perform actions, and finally, an LLM synthesizes all the information into a final output. This type of agent meets our Level 3 requirements, possessing both reasoning and autonomous execution capabilities. The evolution of AI agents has progressed from simple prompt answer to RAG to a single agent that can execute tools. By combining many tools with a reasoning loop, reflection, refinement, and retrying, we get a multi-agent system which represents a more complete agent functionality today. To put it another way, an agent has a conductor inside. This brain understands our goal, draws on past experiences from short-term and long-term memory, and uses a model to reason and plan. For instance, to find a research paper, it will devise a searching strategy. Once the plan is set, it calls upon tools to execute it. These tools can accomplish tasks via API, function calls, or database queries and return the results. The conductor can select the best model for each step, creating a modular and powerful configuration. Next, let's look at a third, more advanced application. We've seen the deep research example. For personal assistance and automation, we can look at the official agent feature ChatGPT launched less than a month ago. It can automatically find electric vehicles and SUVs under $45,000, or automatically search for and order a top-rated kitchen mixer.
And to walk you through what's happening, here's Lisa.
Yeah, so as mentioned, we gave the agent access to its own virtual computer, and the computer has many different tools installed, and it can choose which to use as it's working through the task. So in ChatGPT, you can see a visualization of the agent's computer screen, and you can see overlaid its chain of thought in text, and that's what it's thinking as it's working through the task and deciding what to do next. We gave the agent access to two different ways to browse the internet. First, we gave it a text browser, and this is similar to the deep research tool, and this is what lets it really efficiently and quickly read many web pages and search for them. And we also gave it access to a visual browser, and this is similar to the operator tool. And this is what lets it actually interact with the UI of a web page. So it can drag things, it can use the cursor to click around, it can open UI components, it can fill out forms and enter text in text areas. It's very flexible. So those two tools are very complementary. And then we also gave it access to its own terminal so that it can run code, and it can also generate and analyze files like slide decks and spreadsheets. And then through the terminal, it's also able to call APIs. So both public APIs and APIs to access your private data sources like Google Drive, Google Calendar, GitHub, SharePoint, and many others.
Besides ChatGPT, there are workflow automation tools like Make, N8N, and Diffie. They use a flowchart-based interface to connect processes. When combined with an agent, they enable no-code or low-code solutions, ideal for handling repetitive tasks or generating standardized reports. The evolution of MedAgent Zero involves learning from both successful and failed cases. An agent doesn't just do, it must also learn. In this architecture, when a patient makes a query, a medical agent asks questions and generates an answer, like a doctor. It then enters a reflection phase to verify the answer. If correct, the process is saved to a record library, becoming long-term memory. If incorrect, it reflects on the error and the correct standard, then re-answers. This verified experience is also stored, embodying both memory and learning. Medical agents can be applied in many areas, such as clinical decision support. They can enhance diagnosis, analyze medical images, create personalized treatment plans, assist in drug discovery, and even support robotic surgery. All these medical applications can learn, remember, and reflect through automated tools.